Welcome back, everyone. I am Mr. Wooten, and in today's video, we're going to see how we can review the skill known as combining like terms and how we can use that skill to help us simplify expressions. So let's go ahead and jump right in. So, as we begin to look at combining like terms today, what we want to first do is see our key questions. We've got three of them, just like the last video. So here they are. What are the parts of a term? What are like terms? And how do we combine like terms? So these are the three focuses we want to have. And hopefully by the end of this video, you'll be able to answer each of these three questions. So as we talk about the first question, what are the parts of a term? We're going to give you a word bank here in your note sheet. And I want you to use these 5 terms and use these to fill in the blanks as you're going through. So our first question, when we talk about what are the parts of a term, we want to make sure we understand when we use the word variable, what that refers to. And a variable is a letter that's being used to represent one or more numbers. Okay, so that's our first bullet point. Second, a term is a part of a polynomial that is being added or subtracted. So when we look at our polynomials that we introduced in the previous video, each of those pieces that's added or subtracted together, those all represent terms. Then a coefficient would be the number part of a term. So if we think of a term such as, we'll make one up here, maybe 4x to the 5th power, if that's our term, then the 4 is the number part, and that's the coefficient for this particular term. Next up, a constant term. This is a term with a number part but no variable, right? And we discussed this in our first video. So those constants are the values where we know the exact number and we are either adding that value or subtracting that value in our polynomial, or in some cases, if it's just a constant polynomial, that may be the whole thing, but it's just a value with no variable. And finally, like terms. Like terms are terms that have the same variable parts. So when we talk about same variable parts, what we're referring to here is the parts that have the variable, but it's not just the variable itself, it's the variable and any attached exponents that go with it. So here's an example of two terms, 4x and 7x. Because these have the same variable parts, the one on the left has an x, the one on the right has an x as well, these would be like terms. Okay. Now let's look at this in a slightly different way. What if we had 4x and 7x squared? Well, they have the same variable, but the exponent is different. This one has an exponent of 2, and this one, we don't see an exponent, which means there's sort of a hidden exponent of 1 there. Because these are different, these would not be like terms. So just because they have the same variable, that's not enough. To be like terms, they have to have the same variable and exponent, and we call those the same variable parts. All right. Now let's go through some examples and try to determine, are these or are these not like terms? Now, the first one, 4x and 3x, and then the next one, 5xy, negative 8xy. What I would suggest you do at this moment is pause the video and see if you can go through and just fill in the middle column, yes or no, in your table. Are these like terms or not? And then press play again on the video and see if you can identify then which ones you got right, which ones you got wrong, and try to clarify maybe any misunderstandings or any questions you have. So pause this for just a second and try that out. All right, so let's resume. The first one, hopefully you said, yes, those are like terms. 4x and 3x both have an x. They have the same variable part, so they are like terms. The second one, also yes. 5xy and negative 8xy, those also have the same variable part. Both of them have the xy variable part. And anytime you have multiple variables side by side, just remember that just means an x number times a y number together to get some other value. But it's treated the exact same way. They just have to have the same variable or variables and the same exponents, and this one does. The third one is also considered like terms. These are just both constants because neither one of them has a variable. So 4 and -2 are like terms. The fourth one, 5x and 2, those are not like terms. Why? Well, because the first one has a variable, and the second term, the 2, is just a constant. So these are not like terms. The second one doesn't have a variable part, and the first one does. Next up, 4x and 3y. Hopefully you said these are not like terms either. And the reason being, they have different variable parts. So they both have a variable, but the variable is not the same. 4x and 3y would not be like terms because of the different letter. And then finally, for the last one, 4x and 3x squared. These are not like terms either because one of them has x squared and the other just has x, or x to the first power. So different variable parts here once again. So go back and make any corrections if you tried these problems before you watch the rest of the video clip, and make sure that you have an understanding of what makes each of these like terms or not like terms. So now that we have talked about the parts of a term and we've talked about what like terms are, now we want to see sort of the final piece of the puzzle here, and that is how do we combine like terms? And the idea is we just want to rewrite these expressions that have like terms in more simple terms. The way we do that is we look for things that are like terms and we combine them by adding or subtracting. So in this first example, we have m plus 3m, and that hopefully you can clearly see would just add up to be 4m because the first one, that m represents 1m, and then we're adding 3 more m. That makes a total of 4m. Okay. Next problem, 4r plus -3r. Well, in this case, we have a positive plus a negative. Now, anytime we add a negative value, remember that that moves us, instead of giving us a larger value, if we were to imagine a number line, thinking back to when we learned how to add numbers, if I started at the number 4 and I added 3, I would normally move to the right, and that would take me to 7. But that's not what we're doing here. In this case, we are adding -3. That moves us the opposite direction on the number line. So it's actually more like 4 take away 3, which would put us at 1. So 4r plus -3r, that makes a total of 1r, or we could just say r. Third example, 8w minus w. Well, once again, the second term here doesn't have a coefficient, but there's sort of a hidden 1 there. So this is 8w minus 1w. I think we can all tell that that's going to be 7w. Again, like terms because they have the same variable, and then we just combine them by adding or subtracting the coefficients. Now we get to this one, 9 plus 7y minus 2 minus 5y. And in this particular problem, now there are different terms that we can combine with each other, but we can't combine them all together because they're not all like terms with one another. So when you come across a problem like this, there's different strategies you can use to combine them. One that I've typically taken in the past with students is to create columns and sort of organize and group them by like terms on your paper. So here's what I mean by that. I want to make a column where I store the numbers that are constants that don't have variables. So I want to put a 9 here. And then I'm going to look for any other constants. We see there's a -2 here as well. And what I do is I group them into sort of a column, almost like I'm making a little almost like a little table where we split up the like terms by columns. So I have a 9 and a -2. Notice how I brought down the negative sign as well. Anytime you see an operation symbol like a plus or a minus in front, use that to determine whether the term is positive or negative when you're writing it down. So now let's go back and let's take a look at the other terms we have here. I'm going to switch colors for this. So we also have plus 7y and minus or negative 5y. And now we have these terms grouped by like terms. So my constants are in the first column. If I combine those, 9 take away 2 makes 7. And then if I combine the y terms, 7y take away 5y is 2y. And notice the y part stays the way it is. The variable part never changes when you're combining like terms. I would never say y minus y is just a constant. Okay, 7y minus 5y. That's not just 2. That's going to be 2y. All right, so you maintain the variable part and you just combine the coefficients. Because we ended up with a positive 7 and a positive 2y, to write our final simplified answer, typically you would write variables first and then your constants last. Again, we saw in our last video that standard form is when we put things in terms of the biggest exponent in the expression down to the smallest or down to the constant if it's a polynomial. And so this is sort of like just writing it in standard form with the variables first and then the constants at the end. 2y plus 7. Last couple. 8y plus 2. Is there anything we can combine here? Hopefully you look at this and you think to yourself, these don't seem to be like terms because this one has a y and this one is just a constant, right? So because of that, all we can do is leave this one exactly like it is. 8y plus 2. Down here, 5x minus 4y plus 3x minus negative 6y. As I look at this one, I see a couple of sets of terms that I believe could be like terms. I see a 5x and a 3x, and then I see some y terms here, negative 4y, and then we have this minus negative 6y. We haven't seen one of these just yet in our videos, but what happens when we subtract a negative term? Okay. So we spoke about this a little bit earlier. If we were adding a positive term, we go to the right. If we subtract, we go to the left. If we add a negative number, we go to the left. And so if we subtract a negative number, that means we actually need to go the opposite direction that subtraction normally goes, and that would take us to the right. And so this is where some people have seen or described this as like minus a negative turns into plus a positive, right? But the idea is we're just taking the normal direction of things and we're just making them opposite. So subtracting a negative is really like adding 6y, okay? So now let's group these by like terms. Again, I'm going to write these out in columns. I have 5x and 3x. Both of those have an x variable part. And then the y terms, we have negative 4y. And again, the subtracting negative 6y is the same as just a positive 6y term. And then when we combine, that leaves us with a total of 8x. 5 plus 3 makes 8. And then negative 4 plus 6, I like to think of anytime you're combining a negative and a positive, it's just like you're subtracting one of the numbers from the other, right? So this is 6y, the positive one, minus 4y, that makes 2y. And then I'm going to write this out. I have a positive 8x and a positive 2y. That becomes 8x plus 2y as our final expression there. All right, so let's recap. We answered the question, what are the parts of a term? You took the different values or the different vocabulary terms from our word bank, and we described each of those, a variable, a constant, coefficient, what it means for things to be like terms, each of those things. We then also talked about what like terms were. Those are the terms that have the same variable parts. And when we say variable parts, we mean the same variable and the same exponent. And then in our examples, we went through practicing combining like terms where we group them based off of their variable parts, and then we combine them looking at their coefficients. So you're going to get some practice in class on these, but if you want to go ahead and give yourself a little challenge, If you will, please take a piece of paper and try these two show me what you got questions. And these are typically going to be sort of challenge questions to make sure you really understand what the topic is trying to get across. So, first, can you create an expression that has 5 terms that meet the following criteria? Out of those 5 terms, can you make 2 pairs of like terms and then 1 term that is unlike all the others? Can you also make sure that your expression has a variable part of one of them, including an exponent? So, one of the pairs of like terms should have an exponent in common. And then finally, can you also make sure that your expression has at least one constant term in the expression? So see if you can understand those vocabulary terms that are describing the characteristics of this expression and make this 5 term expression. And then the second one, can you also create an expression with 6 terms where they are all like terms and then rewrite it by combining your like terms? So try those 2 challenge questions out, bring that with you to class, and we'll see you then. Good luck.